According to National Electrical Code Section 516.3d, the location of the exhaust motor is considered unclassified, given it's more than 10 feet away from the open face of the spray booth. This distance is crucial because the open face is where hazardous vapors are most likely to be present. Regarding the opening in the ductwork for the belts, the code doesn't specifically address this. However, it's imperative to properly seal the opening to prevent hazardous vapors from entering the motor compartment. A flexible boot or another suitable material can achieve this seal. For the fluorescent fixtures, only the two fixtures within the 3-foot zone, as shown in Figure 516.3b, need to be fed as Class 1 Division 2. The other two fixtures, being outside the hazardous zone, can be fed as non-hazardous fixtures. The exhaust motor's location, if it is more than 10 feet from the spray booth's open face, is classified as unclassified because that is where the hazardous vapors are likely to be present. The opening in the ductwork needs to be sealed to prevent the entry of any of these hazardous vapors. This can be done with a flexible boot or other suitable material. Fluorescent fixtures are handled differently depending on their location. The fixtures within the 3-foot zone of Figure 516.3b need to be fed as Class 1 Division 2, whereas the fixtures outside of this area can be wired as non-hazardous fixtures. In summary, the area beyond 10 feet from the spray booth is considered unclassified. The ductwork opening must be sealed. Only the two fluorescent fixtures within the specified zone require Class 1 Division 2 wiring. It's essential to understand the implications of these classifications and requirements. The National Electrical Code, or NEC, sets the standard for safe electrical installations. It classifies locations based on the potential for fire or explosion hazards due to the presence of flammable gases, vapors, dust, or fibers. These classifications determine the type of equipment and wiring methods required to minimize the risk of ignition. Class 1 locations are those where flammable gases or vapors are, or may be, present in the air in quantities sufficient to produce explosive or ignitable mixtures. These locations are further divided into Divisions 1 and 2. Division 1 locations are those where ignitable concentrations of flammable gases or vapors exist under normal operating conditions, or where they exist frequently because of repair or maintenance operations or because of leakage. Division 2 locations are those where ignitable concentrations of flammable gases or vapors are handled, processed, or used, but in which the liquids, vapors, or gases are normally confined within closed containers or closed systems from which they can escape only in case of accidental rupture or breakdown of such containers or systems, or in case of abnormal operation of equipment. Understanding these classifications is crucial when dealing with spray booths. Spray booths are environments where flammable liquids are atomized and sprayed, creating the potential for ignitable concentrations of vapors in the air. Therefore, spray booths are typically classified as Class 1, Division 1 or Division 2 locations, depending on the specific conditions and the measures taken to mitigate the risk of vapor accumulation. However, not all areas around a spray booth are necessarily classified as hazardous. The NEC recognizes that the concentration of flammable vapors decreases with distance from the source, and it allows for the establishment of unclassified areas beyond a certain distance. Section 516.3 outlines the specific requirements for determining the extent of classified locations around spray booths. As you stated, subsection D addresses the area around exhaust outlets. It states that the area within 10 feet horizontally from the exhaust outlet and extending 3 feet in all directions from the outlet is typically classified as Class 1, Division 2. However, the area beyond this distance is considered unclassified. This is based on the assumption that the exhaust system is properly designed and maintained to effectively remove flammable vapors from the booth and prevent them from accumulating in hazardous concentrations beyond the specified distance. Therefore, if the exhaust motor is located more than 10 feet from the open face of the spray booth, it would indeed be located in an unclassified area, as long as the exhaust system is functioning correctly. The opening in the ductwork for the belts raises a valid concern. While the NEC doesn't specifically address this situation, it's important to consider the potential for flammable vapors to enter the motor compartment through this opening. If vapors were to accumulate inside the motor compartment, they could create an explosion hazard. Therefore, it's recommended to seal the opening in the ductwork to prevent the entry of vapors. As you mentioned, a flexible boot or other suitable material can be used to achieve the seal. The type of material used should be compatible with the chemicals being sprayed in the booth and should be able to withstand the operating conditions, such as temperature and humidity. The selection of fluorescent fixtures is another important consideration. The NEC requires that electrical equipment located in Class 1, Division 1 or Division 2 locations be specifically designed and approved for use in such hazardous environments. This equipment is typically explosion-proof or intrinsically safe, meaning that it is designed to prevent explosions or limit the energy available to ignite flammable vapors. However, the NEC also recognizes that certain types of equipment may be used in Division 2 locations without being specifically approved for hazardous locations, provided that they are installed in accordance with certain requirements. Section 516.4c addresses the use of lighting fixtures in spray booths. It states that lighting fixtures located within the spray booth enclosure must be of the type approved for Class 1, Division 1 locations. However, lighting fixtures located outside the enclosure but within the 3-foot zone specified in Figure 516.3b may be of the type approved for Class 1, Division 2 locations, or they may be of a type that is not specifically approved for hazardous locations, provided that they meet certain requirements. These requirements include being totally enclosed to prevent the escape of sparks or hot metal particles and being protected from physical damage. In the case of the 4 fluorescent fixtures, 2 of which are within the 3-foot zone, only the 2 fixtures within the zone need to be fed as Class 1 Division 2. The other 2 fixtures, being outside the hazardous zone, can be fed as non-hazardous fixtures. However, it's important to ensure that all 4 fixtures meet the requirements for protection from physical damage and that they are properly grounded. Regarding the use of celtite whips, these are commonly used to provide flexible connections to electrical equipment in hazardous locations. However, it's important to ensure that the celtite fittings are properly installed and sealed to prevent the entry of vapors into the conduit system. In addition, the celtite whips must be of a type approved for use in hazardous locations. It is always best to consult with a qualified electrical inspector or engineer to ensure that the installation meets all applicable codes and standards. The NEC is a complex document, and its interpretation can be challenging, especially for those without extensive experience in hazardous locations. By consulting with an expert, you can ensure that the spray booth is installed safely and in compliance with all applicable regulations. In summary, understanding the classification of locations around a spray booth is essential for ensuring the safety of the installation. The NEC provides specific guidance on how to determine the extent of hazardous locations and what types of equipment and wiring methods are required. The exhaust motor, if located more than 10 feet from the open face of the spray booth, is typically considered to be in an unclassified area. The opening in the ductwork for the bell should be sealed to prevent the entry of flammable vapors. Only the fluorescent fixtures within the 3-foot zone need to be fed as Class 1 Division 2. And all electrical equipment must be properly grounded and protected from physical damage. The area around a spray booth can be divided into different zones based on the likelihood of flammable vapors being present. These zones are classified according to the NEC, and the classification determines the type of electrical equipment that can be used in each zone. The area immediately surrounding the spray booth is typically classified as Class 1, Division 1. This is because this is the area where flammable vapors are most likely to be present under normal operating conditions. The area within 3 feet of the spray booth opening is typically classified as Class 1, Division 2. This is because this is the area where flammable vapors may be present under abnormal operating conditions, such as during a spill or leak. The area beyond 3 feet of the spray booth opening is typically classified as unclassified. This is because this is the area where flammable vapors are not likely to be present in sufficient quantities to create a fire or explosion hazard. The type of electrical equipment that can be used in each zone is determined by the NEC. In Class 1, Division 1 zones, only explosion-proof equipment is allowed. Explosion-proof equipment is designed to contain any explosion that may occur inside the equipment, preventing it from igniting flammable vapors in the surrounding atmosphere. In Class 1, Division 2 zones, either explosion-proof equipment or equipment that is intrinsically safe is allowed. Intrinsically safe equipment is designed to limit the amount of energy that can be released by the equipment, preventing it from igniting flammable vapors. In unclassified zones, any type of electrical equipment can be used, as long as it is installed in accordance with the NEC. In addition to the type of equipment, the wiring methods used in each zone are also determined by the NEC. In Class 1, Division 1 and Division 2 zones, the wiring must be installed in rigid metal conduit or in a cable system that is approved for use in hazardous locations. The conduit or cable must be sealed to prevent flammable vapors from entering the conduit or cable system. In unclassified zones, the wiring can be installed in any type of conduit or cable that is approved for general use. It is important to note that the NEC is a minimum standard. In some cases, it may be necessary to exceed the requirements of the NEC to ensure the safety of the installation. For example, it may be necessary to install explosion-proof equipment in an unclassified zone if there is a risk of flammable vapors being present due to a spill or leak. It is also important to have a qualified electrician inspect the installation to ensure that it meets all applicable codes and standards. A qualified electrician will be familiar with the NEC and will be able to identify any potential hazards. The NEC is a complex document, and it is important to consult with a qualified electrician to ensure that the installation is safe and in compliance with all applicable codes and standards. Understanding the proper classification of areas around a spray booth and the corresponding requirements for electrical equipment and wiring methods is critical for preventing fires and explosions. By following the NEC and consulting with qualified professionals, you can ensure a safe working environment. The NEC defines hazardous locations based on the properties of the flammable substances that may be present and the likelihood of those substances being present in ignitable concentrations. Class 1 locations involve flammable gases or vapors, Class 2 locations involve combustible dusts, and Class 3 locations involve ignitable fibers or flames. Each class is further divided into divisions based on the probability of a hazardous material being present. Division 1 indicates that the hazardous material is present under normal operating conditions, while Division 2 indicates that the hazardous material is present only under abnormal conditions, such as a leak or spill. For spray booths, the primary concern is typically Class 1 locations due to the presence of flammable solvents and coatings. The specific requirements for electrical equipment and wiring in hazardous locations are outlined in Articles 500 through 516 of the NEC. These articles specify the types of equipment that are permitted in each type of hazardous location, as well as the wiring methods that must be used to ensure that the electrical system does not become a source of ignition. Explosion-proof equipment is designed to contain an internal explosion and prevent it from propagating to the surrounding atmosphere. Intrinsically safe equipment is designed to limit the amount of energy that can be released, preventing it from igniting flammable materials. The NEC also addresses the ventilation requirements for spray booths. Proper ventilation is essential for removing flammable vapors from the booth and preventing them from accumulating in hazardous concentrations. The ventilation system must be designed to provide adequate airflow and must be properly maintained to ensure that it is functioning effectively. In addition to the NEC, other codes and standards may also apply to spray booths, such as those issued by the Occupational Safety and Health Administration, or OSHA, and local building codes. It is important to consult with all applicable codes and standards to ensure that the spray booth is installed and operated safely. When working with hazardous locations, it is essential to have a thorough understanding of the applicable codes and standards and to follow all safety precautions. Improperly installed or maintained electrical equipment can create a significant fire or explosion hazard, putting lives and property at risk. Proper sealing of conduit and enclosures is crucial in hazardous locations to prevent the ingress of flammable vapors or dusts. Sealing fittings are used to create a barrier within the conduit system, preventing the migration of hazardous materials from one area to another. The type of sealing fitting that is required depends on the specific application and the type of hazardous location. The NEC provides detailed requirements for the installation of ceiling fittings, including the type of sealant that must be used and the minimum distance between the ceiling fitting and any potential sources of ignition. Flexible metal conduit, or FMC, and liquid-tight flexible metal conduit, or LFMC, are often used to provide flexibility in wiring systems, but they must be properly installed and grounded to ensure safety in hazardous locations. FMC is not typically permitted in Class 1, Division 1 locations, but it may be permitted in Class 1, Division 2 locations under certain conditions. LFMC is permitted in Class 1, Division 1 and Division 2 locations, but it must be listed and marked for use in hazardous locations. The grounding of electrical equipment is essential for preventing electrical shock hazards and for ensuring the proper operation of overcurrent protective devices. In hazardous locations, the grounding system must be designed to minimize the risk of sparking, which could ignite flammable materials. The NEC provides detailed requirements for grounding electrical equipment in hazardous locations, including the type of grounding conductors that must be used and the methods for bonding equipment together. Regular inspections and maintenance are essential for ensuring the continued safety of electrical equipment in hazardous locations. Inspections should be performed by qualified personnel who are familiar with the applicable codes and standards. Maintenance should include cleaning equipment, tightening connections, and replacing worn or damaged parts. Any repairs or modifications to electrical equipment in hazardous locations must be performed by qualified personnel and must comply with all applicable codes and standards. When working in hazardous locations, it is important to wear appropriate personal protective equipment, or PPE, such as flame-resistant clothing, safety glasses, and gloves. PPE can help to protect workers from electrical shock, burns, and other injuries. In addition to the technical requirements of the NEC, it is also important to consider the human factors that can contribute to accidents in hazardous locations. These factors include inadequate training, poor communication, and complacency. By addressing these human factors, it is possible to reduce the risk of accidents and create a safer working environment. Remember to consult with qualified professionals such as electrical engineers and certified electricians to ensure that your electrical installations in hazardous locations comply with all applicable codes and standards and are designed and maintained for optimal safety. It is also crucial to stay updated on the latest revisions and interpretations of the NEC and other relevant codes and standards. Changes in technology and industry practices can lead to updates in the codes, and it is important to be aware of these changes to ensure that your installations remain compliant and safe. When designing electrical systems for hazardous locations, consider the specific properties of the flammable materials that will be present. Different flammable materials have different ignition temperatures and explosion characteristics, and the electrical equipment must be selected and installed accordingly. Proper labeling and signage are essential for identifying hazardous locations and for providing warnings about potential hazards. Labeling should be clear and concise, and it should comply with all applicable standards. Signage should be placed in conspicuous locations to alert workers and visitors to the presence of hazardous materials and the precautions that must be taken. Develop and implement a comprehensive safety program for working in hazardous locations. The safety program should include training on the hazards of flammable materials, safe work practices, and emergency procedures. The safety program should be regularly reviewed and updated to ensure that it remains effective. In the event of an accident in a hazardous location, it is important to have a well-defined emergency response plan. The emergency response plan should include procedures for evacuating the area, shutting down equipment, and contacting emergency services. The emergency response plan should be regularly practiced to ensure that everyone knows what to do in the event of an emergency. By following these guidelines and taking a proactive approach to safety, you can minimize the risk of accidents and create a safe working environment in hazardous locations. When dealing with electrical installations in hazardous locations, it is crucial to prioritize safety above all else. Shortcuts or compromises in safety can have devastating consequences. By taking the time to understand the applicable codes and standards, following safe work practices, and consulting with qualified professionals, you can help to ensure that your electrical installations are safe and compliant. Remember that working in hazardous locations requires a high level of knowledge, skill, and attention to detail. It is not a task to be taken lightly. By approaching the task with professionalism and a commitment to safety, you can help to protect yourself, your coworkers, and the public. In addition to the topics already discussed, there are a few other considerations that are important when dealing with electrical installations and spray booths. These include the use of static electricity control measures, the selection of appropriate overcurrent protection devices, and the proper installation of grounding and bonding systems. Static electricity can be generated by the movement of fluids and air in a spray booth, and it can be a source of ignition for flammable vapors. To control static electricity, it is important to ground all conductive objects in the spray booth, including the spray booth itself, the spray guns, and the objects being sprayed. In addition, anti-static sprays or coatings can be used to reduce the buildup of static electricity. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. In hazardous locations, it is important to select overcurrent protection devices that are appropriate for the specific application and that are rated for use in hazardous locations. The overcurrent protection devices should be installed in enclosures that are designed to prevent the ingress of flammable vapors or dusts. Grounding and bonding systems are used to provide a low-impedance path for fault currents to return to the source. In hazardous locations, it is important to properly ground and bond all electrical equipment to minimize the risk of electrical shock and to prevent the buildup of static electricity. The grounding and bonding system should be designed and installed in accordance with the NEC. When working with electrical installations and spray booths, it is important to be aware of the potential hazards and to take the necessary precautions to protect yourself and others. By following the applicable codes and standards, using appropriate equipment and materials, and following safe work practices, you can help to ensure that the electrical installations and spray booths are safe and compliant.